All right, today we're pulling back the curtain on something you see all the time but probably don't think twice about: the grid substation. Seriously, this thing is the unsung hero of our electrical world, working around the clock to power pretty much everything we do. So let's break down how it all works.
So, have you ever really truly stopped to wonder what happens when you flip a light switch? I mean, that power feels instant, right? Almost like magic. But the truth is, that electricity has been on an incredible journey just to get to you.
And yeah, looking at this, you can see it's definitely not a straight line from the power plant to your living room. It's this huge, complex web. Power gets generated, then it has to travel long distances, and then it gets distributed out to your neighborhood. And all along that path, there are these critical checkpoints that manage the whole show. Okay, so let's actually trace that epic journey from the very beginning to the very end. Because once you understand this path, you'll see exactly why substations are so incredibly important. It really boils down to four main stages. First, you've got generation, where the power is actually made. Then comes transmission. Think of this like the massive superhighways for electricity, carrying power across the country on high voltage lines. After that, we get to distribution, which is like the local city streets, routing that power to your block. And finally, there's consumption. That's you, right now, using that power. But here's where things get interesting. To move all that power around, we hit a really big challenge. It's this sort of necessary paradox that's all about voltage. I mean, just look at these numbers. The difference is staggering, right? For that long distance trip, electricity gets cranked up to an insane 230,000 volts. But what comes out of your wall? Just 230 volts. That's 1,000 times less. So what gives? Why the huge gap? Okay, here's the deal. Think of high voltage like a fire hose. It's awesome for blasting a ton of power over a long way with almost no waste. But you would never use a fire hose to water your little houseplant, right? It's way too powerful, way too dangerous for your home. Low voltage, on the other hand, is perfectly safe for all our gadgets. But if you tried to send it across the country, most of it would just fizzle out as heat. So, we need both. How do we do that? Well, you do it by introducing the real hero of our story, the substation. This is the piece of the puzzle that brilliantly solves that whole voltage paradox. To put it simply, a substation is an electrical translator. It takes that super high voltage electricity and translates it down to the low voltage power we can safely use. And it can do the exact opposite too. It's the essential middleman for the entire grid. And it's not a one-trick pony. It juggles four really critical jobs. It steps up the voltage so power can travel efficiently. Then it steps it down so it's safe for us. It also acts like a traffic cop, switching power from one line to another to manage the flow. And last but not least, it's a protector. It's constantly watching for faults and can cut off a line to prevent damage to the rest of the grid. Now, you might be picturing one of these things in your head, but the thing is, while they all do the same basic job, they can look dramatically different from each other. Let's get into the two main types you're going to see out there. And the biggest difference between them all comes down to one simple thing: insulation. All those high voltage parts have to be kept safely apart from each other. Otherwise, you'd get a massive short circuit. And how they do that is what makes them so different. Wow, and this slide just says it all, doesn't it? On the left, that sprawling outdoor maze of wires and towers, that's an air-insulated substation, or AIS. That's probably what you think of. But on the right, that super compact, clean indoor setup, that's a gas-insulated substation, or GIS. Totally different vibe. So why the huge difference? Well, the AIS on the left just uses the air around it for insulation. And air works, but you need a lot of space between components, which is why these things are massive, and you usually find them out in rural areas. The GIS, though, uses a special gas called SF6. It's a way, way better insulator than air. That means you can pack all the equipment super close together, making the whole thing up to 10 times smaller. And that's perfect for a crowded city where every square foot costs a fortune. Okay, so that's the hardware, the muscle of the system. But what about the brains? What's actually making sure this incredibly complex dance runs smoothly? Well, every single substation has its own little local brain. It's called the control building. This is the nerve center right on site where operators can keep an eye on things, check for any problems, and manage the local equipment. But let's be real, local control isn't enough when you're talking about a grid that powers an entire nation.
You need a master control room, a bigger brain that can see everything, everywhere, all at once.
And that is the National Control Center, or NCC. This is basically mission control for the country's power. They use this incredible system called SCADA. It stands for Supervisory Control and Data Acquisition. But really, it's just a way for them to see and control every power plant, every substation, and every major power line in the entire country, all in real time. And the job they do is just immense. They are watching the grid 24/7, constantly making sure that the amount of power being generated perfectly matches the amount we're all using. That's a crazy balancing act. They schedule maintenance to keep things from breaking, and they even manage buying and selling electricity with neighboring countries. It's a nonstop effort to keep the whole system stable. So let's bring this all back home. Back from that massive power plant through this whole complex journey right to the outlet you're using at this very moment. At the end of the day, this whole hidden network of translators and traffic cops and protectors, it's the backbone of our modern lives. Every single time that voltage needs to be stepped up or stepped down, there is a substation there, working silently in the background, making it all happen. So the next time you flip a switch and your room just instantly lights up, maybe you'll give a little nod to the invisible giant that makes it all possible. This complex, brilliant, and absolutely vital grid with the humble substation right at its heart, just tirelessly powering our world.